So I'm just starting recording as well.
Okay.
All right.
The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. This is Topher Buck. I'm the IC2 project manager at NUMOA, and I'm here to welcome you all to the webinar today. We are really thrilled to have Alex Stone from Washington State Department of Ecology and Margaret Whittaker from ToxServices to give a webinar on evaluation of the Interstate Chemicals Clearinghouse Alternatives Assessment Guide. I'm going to just do a couple of quick introductions and then we'll get started. I'll start showing the slides and we'll get rolling. We've got a lot of material to cover today. So just a few sort of quick logistical pieces of information. First, I assume most, if not all of you, are familiar with GoToWebinar. If you're not, take a minute to sort of familiarize yourself with the control panel, which in all likelihood has appeared on the left side of your screen. We're going to take questions in a sort of Q&A session at the end of the webinar, but certainly if you think of questions during the webinar that you would like to submit, please feel free to do so. There's one, again, if you're familiar with this, one of the interfaces or one aspect of the interface on the control panel is a question box, and you are welcome to type questions in, and we will go through those, or at least as many as time allows, toward the end of the hour. And I also did want to let you know that we are recording this webinar, and we'll make the recording available through the IC2 website, not too long after the webinar. I mean, maybe not tomorrow, but certainly within the next week or so, we will make that available. So I'm just going to give a brief introduction to our speakers. I know that many of you that know them well and don't need the introduction, but for those of you that don't, we're really privileged and pleased to have Alex and Meg presenting today. As I said, Alex Stone is a senior chemist at the Washington State Department of Ecology, where he's worked for the past 22 years. He currently functions as the Safer Chemical Alternative Chemist for the Hazardous Waste and Toxics Reduction Program. He, as you know, as many of you know, he's been intimately involved in the IC2 from the outset, and chaired the work group that created the IC2 Alternatives Assessment Guide. Alex was also a peer reviewer of the National Academy of Sciences framework to guide selection of chemical alternatives. Alex works on a number of chemistry-related projects, including Washington's Chemical Action Plans, Safer Chemical Alternative Assessments, and Children's Safe Product Act. And he also acts as an advisor to ecology management on chemical policy and other chemistry-related issues. Margaret Whittaker, sorry, in case it's not clear, Alex and Meg are both have doctorates. I should have mentioned that. So Dr. Margaret Whittaker has 20 years of experience in both the performance and management of toxicology and human health, hazard and risk assessment related projects. She's currently the managing director and chief toxicologist of ToxServices LLC, where she serves as the project manager and technical lead of ToxServices projects for the U.S. EPA's Design for the Environment program, for the Green Screen program, Clean Production Action's Green Screen program, testing laboratories, consumer products companies, and she works on products ranging from food additives, food contact materials, cleaning chemicals, fragrances, electronics, cosmetics, so on and so on. As project manager and technical lead for contacts with these organizations, Dr. Whittaker has contributed to and/or managed the development of hundreds of human health risk assessments, chemical hazard assessments, exposure assessments, as well as hundreds of product-specific tox evaluations, and she specializes in conducting chemical hazard assessments and chemical alternatives assessments. So let me get us going here. I am going
That's
to,
a nice introduction, Topher. This is Meg.
of course.
For that, I'm bringing you back Marmite that I've been taking from this hotel over here in the UK during British Toxicology Society, and have a collection of 6 little tubs for you. So hopefully I won't get stopped at the border bringing this back.
Thank you.
I don't know. It sounds like a dangerous substance to me.
Right,
No,
yes,
it
exactly.
is. It tastes like liquefied cigars, but Topher seems to like it. So.
All right, so actually I'm trying to, I'm sharing my screen, but I'm having an issue with the controls for GoToWebinar. I apologize, just one moment.
Well, and while you're doing that, let me just say this is Alex here. I'm going to start out with an introduction to the background of the slides, the background of the project, and, you know, why we did it, a little bit of background information. I'm going to try to keep that to a minimum, and then I'm going to turn it over to Meg, who led the team who actually did the assessment. So she will talk to you about the steps that she did and the results and conclusions that she reached, and then I'll come back at the end to talk about next steps. So just to give you an idea, Meg and I will be playing tag team a little bit. So.
All right.
You just have to click on Enable Editing, Topher.
Yes, I'm sorry. It is. Well, there we go.
Dun, 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 dun.
I was trying to put it in slide presentation mode. Unfortunately, it's going full screen in a way that is then interfering with the control panel. So this may be about as good as we can do. Can you?
Sounds like an alternatives assessment. You like
Right,
that?
right.
I can also, if you make me presenter, I can also, I'm at the British Toxicology Society meeting, so I didn't necessarily, over here in the UK, so I didn't want to be the manager of the slideshow, but I can if, I just didn't want to have the Wi-Fi connection go out, so I don't mind if
Well, we
I
can
get the,
we can certainly try that. If just one moment, and I will.
Yeah, because all we're seeing is a black screen right now.
Right. Yes. Apologies.
and to give Topher some credit, this is his day off, or it was.
So I can do that. Again, that may not be, it's not sort of
Right.
full screen.
If you go to slideshow on the tab,
Right.
and you click on that, so there we go.
It's jumping up through the...
And then just go backwards.
Okay.
There we go. Perfect.
Okay.
All right, so why don't we go with the first slide, Topher?
I'm
Okay.
sorry. It is a... Oh, yes, never
I
fail.
wish the project went by this quickly when I
Right,
did
right.
it.
You know, it's funny. Every time I hit next slide, it jumps. All right, Meg, I'm going to try making you the presenter and see if we can get around this, if that's all right.
Okay.
Apologies,
So I need
everybody.
to have the PowerPoint up on my screen then, correct?
Yes.
Correct.
My own PowerPoint. Okay. Go for it. I can see. Let's see. And then let me get my version up and running on my screen. Okay. Let's see.
If it's any consolation, my computer decided to go into update mode, so it took me half an hour to even get connected.
Okay. Here we go. And now I will make this the first slide. Oh, I like this. I get to control everything now, Alex. So let's just make this confirm for me that you see the full screen. Correct, Alex?
I do.
Yes, thank you.
Okay. Whoops. I do not know.
Yes, it's...
Here we go. This is something very strange. All right, let's try and see what I can do. Okay.
Well, I'm glad it's not just me, but...
I'll just be very careful. Everyone will have to be patient. This is, you do with what you got, I guess. Here we go.
Okay, so hopefully starting now, to give a little background information, in January of 2014, so a little over a year ago, the Interstate Chemicals Clearinghouse released the Alternative Assessment Guide, which we're going to call the IC2 Guide from now on, because as everybody knows, there have been a number of guides, including the National Academy of Science, BizNGO, and California's working on theirs, et cetera. But once we were done with the guide, the Department of Ecology was able to find funding to evaluate the 3 frameworks that are in the guide with the intent, and I'll talk a little bit more about the objectives in a moment, of making sure that it's user-friendly, or that someone who wasn't terribly familiar with it could pick up the guide and actually do an alternative assessment. So we put out a request for proposals, and ToxServices led the team that actually got the contract to evaluate the guide. And the intent is to, as I said, evaluate the usability and provide recommendations for improvement, and we'll talk about those results today. Next slide.
Okay, let's see if I do this right. Oh, we're just going to have to hit a couple double. Here we go. There you go.
Okay, so we're going to understand the purpose of the project. We're going to review a little bit about the guide itself, but I'm going to keep that at very high level, very superficial. There have been a number of webinars about the guide itself, so I don't want to spend a little bit too much time about the guide itself. We're going to understand the process for conducting a guide, the project, to conduct the evaluations, review the results and challenges and lessons learned, and then be more familiar with what improvements might be coming to the IC2 guide in the future. Next slide. So to give you a little bit of background on why this was so important, was that we, in Washington State, we have a lot of work that's going on in improving the Puget Sound, and so we've made a commitment to look for all assessments to toxic chemicals, and we've adopted the alternative assessment process to help with cleaning up the Puget Sound. So we created the IC2 guide. As part of that, during the analysis of impacts to the Puget Sound, we also found that copper paint, particularly from aquatic uses like boat paint, et cetera, were negatively impacting the sound. So we looked out there for ways that we could do to evaluate the guide, and we centered on a lot of work that had been done on the copper boat paint issue, and we're using that with some expansion to create a uniform data set which we can then run through the guide itself. And I do want to emphasize, we are not doing an alternative assessment of copper boat paint. We're just using a lot of rich data that was available to evaluate the guide, but some of that information might be used down the road to help us when we actually do an alternative assessment of copper boat paint. So next slide. So I talked about that a little bit. I did want to comment too that the Washington State did pass a law to require the phase out of copper anti-fouling paint beginning in 2018. So there was a lot of work that is going to be coming up that will need support and information on to look at alternatives. And we're a little concerned about zinc being used as the primary alternative to copper, and then there was a lot of organic biocide paints out there as well as non-biocide alternatives. So next slide. So the scope of the project was to, I think, is this the next slide? It is.
See?
Okay, thank you.
Yep, sorry, we'll have to be patient. Every time this happens, everyone, my apologies. It will jump by. I'm not falling asleep. 2 slides, and I'll have to go back.
Okay, so we're focusing for the core of this project is a chemical alternative assessment, and a chemical alternative assessment tries to find alternative chemicals, materials, or product designs to substitute for the use of a hazard chemical. It's important to remember that a chemical alternative assessment is science-based. It is a solution that identifies and completely characterizes chemical hazards that promotes the replacement of toxic chemicals with less hazardous alternatives. And one of the big things we're trying to do is to avoid the problem of regrettable substitutions, where we find that the chemical we've used as a replacement is as bad or worse as compared with the toxic chemical we're trying to replace. So next slide.
Oh, this is so frustrating.
Is to mentioned before, perform a uniform data set. So in order to evaluate the guide, we wanted to remove variations in data as one of the parameters. So what we did is we created a uniform data set, and Meg will talk more about what information was used in that to create that uniform data set. But once we had that one set of data, we wanted to run through the 3 frameworks in the alternative assessment guide And then we set up 3 independent groups to run those assessments so that they all used the same data, but they all did their assessments completely independent of each other. And then they all got together and compared results and provide feedback on the usability and recommendations to improve the IC2 guide. Next slide.
Okay.
So we're going to do a really quick overview of the guide. I mentioned it was in 2014. The 3 frameworks that we are included in the guide are the sequential, where basically you use a sieving approach to focus down on safer alternatives. The simultaneous, where you basically identify alternatives and look at all of the data for all alternatives simultaneously. Or the hybrid, which is really a combination of the 2, where you focus your attention on a few alternatives by sieving down through a couple of criteria, and then once you've got a limited group of alternatives, you look at all the data for that limited group. The IC2 guide, that's a picture of it there, and you can find it on the IC2 website if you haven't seen it before. So next slide.
Let's see if this works. Oh, almost worked.
Okay, and the IC2 guide is a 5-step process. So the first one is to identify chemical of concern, and that's a little bit outside the scope of an alternative assessment. We assumed in the guide that decision has been made. We do an initial evaluation to see if there are any alternatives that are really, or that to determine whether or not an alternative assessment is really necessary. Can you just eliminate the chemical or redesign the product that eliminates the use of the toxic chemical so you don't have to do an alternative assessment? But if you find out you do, you then scope it, you decide what level of stakeholder involvement is necessary, and then which of the 3 frameworks you're going to use. Once you've done that, you decide what is the universe of alternatives that you're going to do, and then once you've decided the universe of alternatives, you go in and assess the alternatives. And there's a number of different criteria to assess the alternatives with. There are 4 recommended: hazard, cost and availability, performance, and exposure, but there's also some optional ones like life cycle thinking, social impact, and materials management that you can use to expand out your assessment of it. So next slide. So the scope of the IC2 project, to evaluate each framework using the 4 basic modules that we've mentioned. We did ask that they look for one of the 3 assessments. They look at the 3 optional modules to see how they fit into the overall assessment and whether or not there was enough information in there to make them useful. And we're going to apply the IC2 golden rule that regardless of which framework was used, the objectives of an alternative assessment must be met, i.e. we want you to look at replacing a toxic chemical with a safer alternative. We're not interested in justifying the continued use of the toxic chemical. The objective is to find a replacement, if possible, for that alternative. So now I'm going to turn it over to Meg and let her take it from here. Meg?
Great. Well, to give the IC2 guide credit, this is version 1, and nothing great was ever completed generally the first time around. So we were very excited as a consortium to look at this and look at it critically and obviously try and improve it where we could. The pilot was designed to test the usability of the IC2 guide. We did want to try and develop also the basis for future AAs because copper anti-fouling paints are on their way out, as you've heard Alex describe. So what we did is we looked at it very methodically. We kind of chopped up the pilot project into 5 major tasks. And under task 1, we created a uniform data set. And we wanted to look at the hazards, both human health and environmental, of all of the individual chemicals in the core paint, meaning copper paint formulation, and then alternative paint formulations. It turned out we looked at 7 paint formulations, as I'll talk about. And then under tasks 2, 3, and 4, 3 independent groups of alternatives assessors completed an alternatives assessment using one of the 3 AA frameworks that's described in the IC2 guide. And then after this process, under task 5, 3 independent organizations, ToxServices, TURI, and Apt Associates came together and we talked about, well, what did we learn? What were the challenges? How can we really improve the IC2 guide for people that practically use and for people who aren't multimillionaires to perform alternatives assessments to make sure that hazardous chemicals are replaced with safer alternatives and that regrettable substitution really is either eliminated or minimized. As Alex said, I want to caveat it as well, these AAs were not created with the intention of being standalone alternatives assessments. These are a good model to follow, but this wasn't the goal of the pilot project. And you can download the report via the IC2 website, and we've given you the link here. It's freely downloadable. And if you have questions, you can either ask me or Alex. We're happy to talk about it. So, whoops, let's go back to 12. So here's kind of just a visual of the project scope. Going through, it was about an 8-month project, 6 to 8 months by the time we got the comments back, et cetera. And that's fairly typical if you're, let's say, a corporation and you've got to get rid of something voluntarily. We wanted to try and be realistic about how long this would take, but we had to work quite hard to meet that deadline. It was quite challenging. So let's see. The first step was to create a uniform data set. Obviously, we wanted to find out what alternative paints can we assess. So what we did is we found 2 reports, one that Cal EPA put together, where they did look at 46 paints, which included biocide paints based on copper and zinc, as well as non-biocide paints. And then there was a US EPA report that was also published in 2011 that we referenced. Kind of the kicker, though, initially I thought, oh, easy peasy. Hazard assessment was not part of the scope of either of those reports. And hazard assessment is a core part of every AA. So therefore, we had to conduct hazard assessments for use in each of the alternatives assessments. So what we did is we data mined these 2 reports to try and find viable alternatives. Now, because hazard wasn't assessed in either of those reports, we used performance as a way to select potential alternatives because we didn't have any hazard assessments to refer to. So we needed our control paint that has copper in it, and we found 6 alternatives that looked like, they might be viable alternatives. All of these alternative paints are classified as soft non-biocide paints. And I've given you the definition of what that means, but the ones we chose, that class is described as either silicon or fluoropolymer-based paints, and they don't have biocides in them. Let's go back here. Okay. So what's the challenge? This is the first challenge we encountered. We did have complete disclosure for 2 paints, thanks to Petit Paint did, in fact, disclose to us the full formulations, or excuse me, Copcoat, who's the owner, of 2 of the 7 formulations. But for the other 5 paints, we were working on disclosure through MSDSs. So as you can see in the table here on the far right column, for one of the paints, because ingredients are listed as ranges on MSDSs, between 12 and 45% of the formulation only was disclosed. In the U.S., because of the hazard communication standard, disclosure is only required for carcinogens present above 0.1% in a formulation or other major toxicants present above 1%. So this is a big challenge everyone is going to have trying to perform alternatives assessments using publicly available data. So that was, and we'll talk about that as we move through this webinar. Go back to, there we go. So our primary tool used to assess hazard was the green screen for safer chemicals, chemical hazard assessment paradigm. We also considered performance and cost, availability, and exposure data, and we drew those from the Cal EPA and US EPA 2011 reports. It's not cheating per se. If something exists, you should use it, and it's good data, or someone's already done it. And as I said before, the purpose of this pilot was to pilot the IC2 guide primarily. So what this entailed was about 55 green screens, and it resulted in a massive uniform data set, a greater than 1,000-page report that has dozens and dozens of chemical hazard assessments. And then we used this, we fed this into the subsequent alternatives assessments. Let me go backwards. So what we did as part of the task one, and it took probably more than 60% of the time of the contract, is we went through a sequential step where we went through and performed hazard evaluations of all of the chemicals that we could identify in the copper-based and 6 alternative paint formulations to create our uniform data set. We tried to use something called the green screen list translator, which you can use through a tool called Pharos as well as Greenworks, which will search list-based tools. We wanted to identify the known bads very quickly, and the green screen list translator can do that, and you don't have to have a PhD or a master's degree to use it. It's actually quite nice. There's a free 30-day trial through Pharos. Then what we did is, if we couldn't easily eliminate a chemical, let's say we know it's a known PBT or it's a carcinogen, we subsequently performed more rigorous chemical hazard assessments, which I'll show you on the next slide. And then these hazard assessments were compiled into our overall uniform data set. And all of these green screens will be publicly accessible. We hope people use them, and they'll be on the IC2 database for a free download. But what the IC2 guide calls for is progressively more rigorous hazard screening. If you can easily eliminate something using something called the list translator, and you can say, wow, I know that it's not a good chemical, it's PBT, meaning it's persistent, bioaccumulative, and toxic, not good for the environment, that's a great way to quickly eliminate something. But generally, you have to go through and do a sequential evaluation. And for this, because let's say something is a carcinogen, a human carcinogen, we also had to characterize its environmental fate and toxicity, because we wanted to know, we wanted to make sure the chemical, each chemical in the alternative paint wouldn't result in some type of adverse environmental effect. So we had to kind of add on and do a little bit of extra work because of that. Let me just go back. So after 4 months of completing dozens and dozens of green screens and list translator screens, we had our uniform data set. What we did then is we fed the results of that into tasks 2, 3, and 4 alternatives assessments. And under the tasks 2, 3, and 4, 3 groups each completed an alternatives assessment. One was the sequential framework, one followed the simultaneous framework, and one followed the hybrid framework. The work was done by ToxServices and by Apt Associates. We wanted to keep everyone independent and separate as much as possible to try and see how running one of the different frameworks would affect the results. All of these AA frameworks share, though, 4 common core modules. You have to characterize hazard, performance, cost and availability, and exposure assessment. And as Alex mentioned earlier in the call, 3 additional modules, materials management, social impacts, and life cycle, were implemented in the hybrid framework by Apt to see whether running these additional modules affected the results of an AA. Let's see, there we go. So the first framework we put together was the sequential framework. I kind of was drawn to that because I think very linearly. And this isn't, the goal of this call isn't to teach you how to perform a sequential framework, to just give you an overview. It's performed, though, in a linear order. When you look at each module, starting out with hazard, you want to bin whatever you're assessing. In this case, it was paint formulations, as unfavorable, less favorable, or favorable as you move through the AA paradigm. And less favorable and favorable formulations proceed to the next module as you keep trying to eliminate those that are unfavorable. And obviously, you can go online and look at our report. You can see on the far right of the screen the illustration of applying the sequential framework. But if you see on the far right where we have 3 unfavorables, we were able to pitch out 3 of the 6 formulations, 1 because of hazard, 1 because of performance, and 1 because of cost and availability, well, actually availability. So we were able to eliminate 3 of the 6. And so at the end of the day, using this alternatives assessment framework, we concluded that 3 of the 6 paints were viable alternatives to the copper-based control paint. Then, with the simultaneous framework, Data are collected and assessed for all the formulations using 4 modules, the core modules that we talked about. But the difference with this one is that modules are performed simultaneously. And then secondly, modules are weighted by the alternatives assessor, with hazard having the highest weight. And then performance, cost and availability, and exposure are weighted equally. I like that, how it advanced. I didn't even ask it to. Using this framework, only one of the 6 paints was selected as a viable alternative, and that was the surface coat Part A black paint. And I'm not going to obviously go through the figure here on the right, but it's important to look at the caveats associated with this framework. None of these paints were perfect. All of them had benchmark 1, meaning avoid, or list translator 1 chemicals, and there are significant data gaps in the formulation. We didn't know 100% of the ingredients. So a couple of caveats with that, with saying that's a viable alternative. And then here's the third framework we applied. Our apt associates took this one on, which was quite challenging. This is the hybrid framework. Again, it also entails application of the hazard and performance frameworks, as well as cost and availability. The interesting thing about this hybrid framework is that hazard is performed first, then performance, to try and throw out less favorable alternatives. And then apt also conducted the 3 optional modules, looking at materials management, social impacts, and life cycle. So it was a very challenging alternatives assessment. So here's the results of the hybrid framework. It is very complicated. We weren't able the first time through to find any viable alternatives. There was no way to say which one was unfavorable. So we had to circle through the framework again and bin hazards, looking at data availability, or looking at which of the paints had more aquatic aquatic toxic chemicals, and we had to go through a few times doing that. And at the end of the day, after applying that and revisiting the decision criteria, 1 paint was selected as a viable alternative, which was a different one than the viable alternative from the other frameworks. So after we ran through the uniform data set, putting all those green screens together, preparing 3 alternatives assessments using the sequential, the simultaneous, and the hybrid framework, our 3 organizations came together and we said, what have we learned? What works? What doesn't? How can we improve the IC2 guide? Was it useful? That was the biggest question. Did it help us select a viable alternative? Was it? And I'm obviously not going to go through this. You can download the pilot project report to look at this massive comparison of the AA results. But as you see on the table on the far right, the sequential framework identified 3 preferred alternatives. The simultaneous framework identified one of the alternatives that was also identified in the sequential framework, and the hybrid framework came up with its own viable alternative. So we said to ourselves, what are the similarities between these frameworks? Because we wanted to look at the similarities and the differences to try and see, are really 3 frameworks needed? An important point is that all frameworks were able quite effectively to, because of the hazard module, to identify bad chemicals. Green screen benchmark chemicals were identified, and then many were eliminated as part of all 3 alternatives assessments. All of the paints performed relatively similarly, except for one alternative that seemed to peel a lot, so we could call that one unfavorable based on poor performance. Cost and availability wasn't a determining factor in saying something was unfavorable. The cost was roughly equivalent. And then the exposure potential, it's also non-differentiating among the alternative paints. So it's interesting to look at and consider. Now the differences. There were significant differences in terms of the decision-making approaches used when assessing potential hazard of the different alternatives. And while each assessor used the same uniform data set of the green screen hazard assessments when completing the hazard module. They did use different approaches to assess hazard for decision making. A key point, and something that we learned, is that every single alternative paint contained at least one benchmark 1 chemical. So there wasn't an easy way to say, oh, this contains a benchmark 1, I won't use this paint, because they all did. They all had at least one ingredient that was not chemically optimized. And so that was challenging. Also, some of the assessors used different decision-making approaches. The assessors of the sequential framework considered chemicals with benchmark 1 scores, which means don't use or avoid. They considered those that were driven by environmental toxicity and fate to have greater importance than those with benchmark 1 scores driven by human health. And that's acceptable as long as you're transparent. I mean, the application of these paints is obviously going to be an environment where there's going to be obviously a lot of exposure to aquatic organisms. So that wasn't an issue, but it's important to talk about because the decision-making criteria was different than the other alternatives assessment framework assessors applied. And then the alternatives assessors handled data gaps differently. And that's why in the sequential framework, there were 3 alternatives identified that were viable. The simultaneous framework only identified 1. And this is going to happen with alternatives assessments as this grows because there's generally going to be data gaps either in formulation disclosure or not every chemical is going to have a complete suite of environmental and health effects data on it. And then an interesting point, the assessors of the hybrid framework just removed any formulations that didn't have adequate disclosure. So they didn't even want to consider one of the formulations because they had no information about one of the components of it. So that's kind of interesting to note. So talking about now the similarities and the differences, what were the challenges that we found associated with using the IC2 guide? The first one was, well, on the framework level challenges, with the sequential framework that probably many people will be drawn to, is that it wasn't clear how to deal with multiple alternatives that remained after the assessment. In real life, when we work with clients, they generally they want to go with one alternative. If they're making a formulation, they may have multiple suppliers within that formulation, but they're not going to want to have 3 different recipes for the same product. That's not very clear right now in the IC2 guide as to, what can we do? How to deal with multiple alternatives after the alternatives assessment. And that's a challenge. And then under the sequential and hybrid frameworks, it wasn't clear how to implement the decision methods. And we need to clone what Tim Malloy to help us all out on this. But the methodology that goes into making the decisions isn't very clear, and it's not something that many people are adequately trained on, so that needed work. Now at the module level, not talking, each framework has modules that feed into it. The greatest challenge that we saw was within the hazard module. And the hazard module consists of 2 parts. There's a hazard evaluation and then assessing hazard for decision making. And there's not a lot of guidance right now for decision making, particularly when, what do you do if all chemicals are green screen benchmark 1? And the guide right now doesn't address incomplete formulation disclosure. So for example, if you have a formulation that has between 39 and 146% of formulation disclosed because people are presenting ranges, what is an alternatives assessor supposed to do? And generally adding additional detail in the core modules for product level alternatives assessments. Because it's easy to just compare one chemical to another chemical, but in real life people are trying to substitute chemicals out of products, and that needs to be bolstered and strengthened definitely. I won't go into great detail with these module level challenges for these other endpoints, but we've identified them, and it's clear that within each of the modules there are adjustments and revisions that are required to make it clearer to the alternatives assessor to ensure that they're making the correct selection and removing unfavorable alternatives instead of allowing those unfavorable formulations to keep moving through the process and potentially being selected as, oh, the viable alternative. So lessons learned. It's interesting to see that, well, although preferred alternatives were identified, you saw that, as I talked about, in each of the AA frameworks, there was at least one preferred alternative identified. We didn't really find a good alternative to copper anti-fouling paint. All of the viable, quote-unquote, alternatives contain chemicals that did pose human health and/or environmental concerns. And then there's significant uncertainty in data due to incomplete formulation disclosure. It would be very hard for me to say I would recommend to a client, oh, switch to this formulation, but I can only tell you I only know 46% of the ingredients. That's something that I guess as the AA community we'll all have to talk about. What will we do if we just can't get that disclosure? Because the key question is we want to select a preferable alternative. And it's obviously if you have incomplete disclosure, that's very difficult to do. That being said, this guide is a valuable resource, and it's flexible because it does allow for multiple modules to be added or subtracted as long as those 4 core modules in the AA are implemented. It does require some degree of technical expertise, particularly the hazard and the exposure assessment modules. Now, obviously as a result of this project, we now have something like 58 green screens that will go into the IC2 database that will be freely available, so that if you don't want to perform a hazard assessment, it will be primarily done for you through something like a green screen, and you can use that and pull it into your module. I mean, that's kind of the goal where we're going to. So here's some other recommendations that we came up with to help someone who's brand new. And the majority of people are brand new at AAs. I just saw that there's an alternatives assessment webinar coming up next month, and none of the speakers, at least to my knowledge, have ever performed an alternatives assessment. So I'm not too sure as we build our community, it's really important that the cookbook, so to speak, be as detailed as possible and contain adequate examples and caveats so that people are performing alternatives assessments to the best of their ability while we grow in our expertise. There's lots of technical edits needed. We work with terminology consistency. We really feel the IC2 guide should change its organizational approach. We'd really like it to focus around the 5 steps of an alternatives assessment so that someone reading the guide who's getting used to that, what's the first step? Identifying chemicals of concern, going through the initial evaluation, scoping, identifying alternatives, and evaluating it. It's not such an overwhelming process. And then just some simple navigation improvements so that it's a 184-page document, the IC2 guide. It's much easier to jump around as you're jumping through the different modules and going back and checking. And those are relatively easy to do. Let's see. We don't need to go into too much detail on this, but that being said, we want to help. We gave a lot of feedback on guidance on framework selection. Some people may not know, is hybrid better than sequential or simultaneous? That's not really clear right now as to which one should be used. And then a lot of work needs to be done on decision making so that it's clear as people are trying to bin and throw away unfavorable alternatives, there's a rationale behind that, and that someone doesn't, just like with a risk assessment, isn't number shopping and doesn't have a preferred alternative from the get-go and then justify selection of that, because we want to eliminate that wherever possible. So we had 3 high priority recommendations from this whole pilot project. We really want to work and have the guide improve on the effectiveness of the hazard module. This is quite important, both in terms of making it easy to perform an AA, but to make sure we prevent regrettable substitution. The the guidance really needs to improve in the IC2 guide on how to use green screen benchmark scores and how to use hazard data that supports scores to differentiate among alternatives. For example, and then, as I said before, the guidance on decision making. There has to be better decision rules so that someone can try and follow a standard process to eliminate unviable alternatives, and then simply improving the organization and flow of the IC2 guide. Alex will go over with you. Well, he came up and he read through our report with all of our recommendations. Alex, what are the next steps in the timeline of taking the IC2 guide to the next level? And maybe he went away.
Sorry, I was on mute.
Oh, good. I was going to come and I was going to make up what I wanted to do, but I thought I'd get in trouble.
I'm sitting here talking away and realizing nobody's hearing me. Okay.
Yeah.
And I do want to compliment Meg and her team. They did an excellent job. And I do want to emphasize one real positive of this assessment is that everything was open and transparent. And I think that's a very important part of any alternative assessment, even though there may have been variabilities in terms of how they made decisions or how they proceeded through each individual step. It was very well documented, so somebody could pick it up and read it and at least understand. They may not necessarily agree on the decisions that were made, but at least they can understand and provide input on it. So I do want to compliment the fact that everything was open and transparent, and that if you look at it in terms of the overall end results, there weren't all that much variability in the end results. So, but what we're going to do in terms of the future is we're having an alternative assessment subcommittee, and we're going to be looking at the recommendations. And basically the intent is to separate them into three groups, ones that are easily implemented. So for example, they're concerned about what do you do if you come down at the end and you have multiple alternatives. We did discuss that in the IC2 during the development of the IC2 guide, and it's clear our decision on that probably did not make it in. And it's very easy just to update it and say, you know, basically that's up to you to decide which of the three that you may want to go with. And it might be at that point you might want to expand your assessment and look at it in terms of, like, you know, energy usage or water usage or CO2 generated or any of these other factors that might help you narrow focus it down into one preferred alternative. But that is left pretty much to the assessor. But that's an example of something that's fairly easily changed, or things like, you know, just changing the structure of it a little bit to better agree to the 5 steps. Those sorts of things are easy. Ones that may be a little bit more difficult and might be outside of our ability to implement in the short term is things like how to handle mixtures. And I know that from the green screen perspective, that's one of the 2 big things that we've agreed as a group to try to tackle, how to handle, you know, making decisions on formulations. Because yes, we've been basing a lot of our work on chemical-to-chemical replacement, but the real world deals with formulations, as this shows. So it may be that the community as a large needs to provide a little bit more input on helping us to develop that. But it's still something that I like about this is it accentuates the fact that it's very important in terms of conducting a good assessment. And then there may be other ones that we present to the technical advisory group that created the IC2 guide to decide if that's something we want to do. So there were several recommendations about new sections, for example, and that wasn't really what our original intent was, but, you know, they're good recommendations and they need to be brought to the larger group to see how we want to proceed with those. So once we've come up as a subcommittee with those sorts of final decisions, we'll go to the governing council, and if we decide to reconvene the technical advisory group, I would hope to do it, you know, towards the end of this summer, beginning of autumn, with the idea of coming out with an updated version by the end of the year. And those are very tentative dates depending upon availability and resources and things like that. But I'd like to take advantage of all of this good work as quickly as we can. So I think those are our next steps. But again, thank you, Meg, and your group for a very good assessment. A good job, well done.
Well, I want to thank Amanda Cattermole of Cattermole Consulting. She was a subcontractor and worked great and was the manager for this. We want people to use the report. There's 51 tables in it, for example, not including the appended tables, where we give you examples of how to look at performance or cost, et cetera. It's how I learned how to run benchmark doses years ago. I got a 3,000-page EPA report, so we want people to use it, and hopefully there'll be constructive criticism in the approaches we took. But we tried to be transparent and show what our rationale was, or maybe wasn't, if you look at our decision making. But
so if you have any questions for me and Meg, I think our next slide is contact information, right?
Mm-hmm. Yep. Let's see if it wants to advance to that. And we've got, our emails. We're both, that's Alex's new email, I guess, correct? Please reach out and contact me. I'm always happy to answer a question or point you in the right direction if I'm not the right person.
And I guess we have a few minutes for questions now, right?
Yes, I was going to say, speaking of questions, we have gotten a few. Okay. And first of all, again, thank you both so much for the excellent presentation. It was great. But let's jump in. So the first question is, did you have hazard data on all the ingredients with the function? I think basically with the function of anti-fouling, which is to say, biocide or some kind of a non-stick function. And if so, were any of them not benchmark 1?
Well, in the green screen, yes, some of them, when you say them, you meaning the ingredients within the formulations.
I think so, and I think specifically the sort of active, so-called active ingredient.
There were many data gaps, particularly when we didn't have complete information on them. There were, as you'll see in the appendix, because we were using for 5 of the 7 formulations, information off MSDSs, so that's publicly available. We include our complete hazard tables. For the 2 CBI formulations, we had to redact that information, so you'll just see redacted tables. But for the other viable alternatives, you'll be able to easily see in the appendix of the report the benchmark scores for the 18 hazard endpoints in a green screen. So there were some, yes, ones that weren't benchmark 1s, but as you'll see when you look through the appendix, we either had data gaps or none of them were perfect, let's say that. And I suppose it might come down to, well, is it less bad? So that if you knowingly go into selecting an alternative, obviously continuous improvement is the goal. Maybe everyone will have to settle on, well, this is less bad than copper. At least we know what the hazards are because we've benchmarked them, or we've identified where the data gaps are with incomplete disclosure, and we can try and work collaboratively with industry to find a safer formulation and get the full, the full formulation from them. Because under green screen, you can still redact the chemical name and CAS number, but show the hazards and protect supplier's CBI. So we're hoping that's where it goes to. But there were some that were safer than copper. I encourage you to look at the appendices and go through them. And anyone can contact me, or if you want to discuss the profile of any of the paints, to respect the manufacturers and not state that one's worse than another. I don't want to call out by name any of the trade names to be fair to those companies who we consider to be making viable alternatives.
Well, and I do want to emphasize, too, that remember the objective of this was not to identify a safer alternative to copper boat paint, to test the guide. And you mentioned, for example, in the 2011 reports, they evaluated as many as 45 alternatives.
That's right.
And those reports are now 4 years old. So there are some new things that are on the market as well. So that when we actually get, and from that larger pool, we only pulled 7 out of it. So there are lots of alternatives that were not evaluated in here that hopefully will be evaluated when we get down to actually doing an alternative assessment on copper boat paint. So don't forget, the goal of this was just to evaluate the guide, not to, but we'll use that as a sort of spring point of, and it'll help to emphasize the need for full disclosure and any sort of hazard information available that the companies might have too, that have not been released and made publicly available.
Okay, great. Thank you. Next question. was there, or did one of the three frameworks make the most sense within the context of this project? Meaning, are there some common sense factors that are difficult, that may be difficult to document, but that might drive one to choose one framework over another, depending on the context of a given alternative assessment?
Mm-hmm. Well, I think as chemical hazard assessments like green screens become publicly available, the sequential framework, assuming you could try and eliminate an unfavorable alternative based on hazard alone, you'd probably be able to ding out a whole bunch of unfavorables if you perform the sequential framework. I don't know, I just think very sequentially, and Alex, you may say, oh, the hybrid's not bad, I suppose. You have to understand performance and as well as hazard. I mean, if the formulation doesn't work, no one's going to buy it. So, I think I'd lean probably towards the hybrid or the sequential myself. But, I found that, so this is in the future, as green screens become more available where you can try and, in some cases, not in every, because as I mentioned before, all of these formulations had benchmark 1, now different percentages, but there wasn't any easy way to say off the bat, we're going to throw this out immediately. But I don't know. Like, maybe Alex can't say he has a favorite one because he's obviously, that would make you biased. But I preferred the sequential or the hybrid, and I thought it was a very good way to try and identify alternatives.
Well, correct me if I'm wrong, Meg, but didn't one of the recommendations that you did not comment on was that you did recommend eliminating the simultaneous from the guide completely?
Well, yeah, but I don't want to bias anyone. I don't think
that's still a recommendation that your report states.
And right, and because I didn't find it very useful. The goal is to do this quickly, inexpensively, and painlessly, because believe me, it causes a lot of pain to have to do, go through a module that isn't useful. So that might be something that if you take that into consideration, Alex, I think there's no need you have to have 3. We were able to, do what we needed to do with either the sequential or the hybrid. So that would be nice if you'd, potentially consider that as you make these revisions. And
well, that's a recommendation that I will take to the technical advisory group and see what their comment on it is.
Okay.
And to answer your question about Alex having a favorite, I won't state that, but what I will state is that Washington State came out with its own guide based on the IC2 guide, and that recommends the sequential.
Oh, interesting. Well, it would be nice someday if we can get to a place where some of it could be automated. Now, obviously, a lot of this has to do with, you're going to consider cost or performance and then life cycle, et cetera, if those modules are used. But really some of the automation with the hazard assessment should be possible to try and easily identify known bads. You don't want to use them. There's no justification for using them. So that's my ideal someday.
Great. I think we can squeeze in one more question, and this one is a little more technical. So the question is, how specifically did you deal with the fact that the motivation for this substitution, I think in the case of the copper boat paint, is water quality protection? And this question goes along with the observation that it seems a little strange that the presentation focused on green screen benchmark 1 as a key criterion, since the benchmark specifically emphasizes human hazards. Emphasizes human hazards over non-human hazards.
Well, and we went into that knowing that. So, for example, on one of the earlier slides, and the slide presentation will be available for download as well. Let's say it was a list translator 1. Often those are carcinogens or mutagens or reproductive toxicants. We would also add to that an environmental toxin fate screen, because for this application, obviously the environment is our focus. The challenge, admittedly, is that environmental hazards don't have to be disclosed on a U.S. SDS or MSDS. So that's an inherent issue in our regulatory system. I didn't have a PNEX, for example, provisional no effect concentrations to work with our MSDSs. And then under the hybrid framework, for example, we did weight benchmark ones for environmental, because the environmental toxin fate's heavier. So we did take that into consideration under one of the frameworks, because you do have to think about, just like with a risk assessment, if you're dealing with like an inhalation toxicant as opposed to an oral route toxicant, you have to think about what are you doing, what's the intended end use of the product. So we did look at that. You know, in terms of the hazard assessment paradigms we looked at to use, we still found the green screen to be, you know, the most robust, and we wanted some kind of score as well. I mean, the DFE, which is now Safer Choice, you know, their AA guidelines, for example, there's no benchmark score. So, so we did consider the environment. We did add and go back and do some extra work to focus and try and make sure that we weren't saying a paint was a viable alternative when in fact it would be, for example, aquatically toxic or, you know, bioaccumulative or persistent. We didn't want that. So that's a really good question. But you do have to tailor your AA for however the product's going to be used. That's a good point. Whoever asked that.
I would also throw in the comment that these products are intended to be aquatically toxic. So it might be that aquatic toxicity is not the main decision point in here, but maybe trying to find ones that are also not persistent, are not bioaccumulative, that don't have human health criteria, and that maybe can have the minimum, that have the appropriate level of aquatic toxicity, but you know, don't stick around for long periods of time, might be the best way of making the decision, because we do have to remember these products have to be functional, and if they're anti-fouling paint, they're by definition going to be aquatic toxic, but maybe also to look at it and see that it's toxic towards the target organisms, but not other organisms in the aquatic environment. So there are ways of fine-tuning this, but there are certain limitations of the process as well that we can't exceed, because these products have to function.
Oh, right, right. These were soft non-biocides, so they're kind of slippery, and the little rascals have a hard time, you know, adhering to the boats. But yeah, definitely you've got to think about, yeah, there's a whole decision-making process that goes into this, and you know, for someone to put together a good AA, it needs to be transparent, and people then, there's obviously always room for disagreement, but as long as you're transparent and the, you know, the thought process that went into it was shown, then people may sometimes just agree to disagree, that it's a difference of interpretation. But you know, if anyone has any other questions, feel free to email me your questions, and I'm happy to, I'll CC you know, Alex and get him in the loop. We're happy to follow up with anyone else. And you know, we hope you enjoy reading the report.
Yeah.
And thank you very much for your time and interest.
Yes. Well, and again, so we are out of time. There are a few questions that we don't have time for, but I know those of you who've asked them can reach out to Alex and Meg directly and get answers to those if you want. And again, I just want to thank you, Alex and Meg, both so much, not only for all the work that you've done on the guide and this evaluation, but of course also for this excellent presentation today. And thanks to all of the attendees for joining us.
Great.
All right.
Thank you, Topher.
All right.
Take care. Yeah.
Bye.
Thank you, everybody. Have a good rest of your day.